Hi everyone, let's talk about what we are going to do today. On the left is a low-rate smoke simulation. We can apply a technique called griddless advection in the post and make this smoke look like a high-rate scene and have more details like this. So let me play it. So as you can see here, this one is more like sharp and has more details. So let me introduce the concept first. So the goal is to make a version of the smoke from itself. What does that mean? Okay, let's say I'm a voxel and I want to steal the density value from someone else in this smoke. So who or where should I steal from? The griddless advection method suggests us take a journey by negative velocities and then copy the density value from this final destination. So let me show you how this goes. Say I'm going to change the density in this position, and the velocity of the smoke is pointing, let's say, this way. So I travel along the negative direction, which is this way, for example here. And again, I check the velocity of the smoke in this position, and the velocity kind of like go this way. So I go to the negative direction like this. And we keep doing this. For example, going this way, here, here, here. Okay. So let us say that we are happy to stop at here. And then at this position, I can query the density value of the smoke and then just copy the value back to my original voxel. So that's the algorithm. Let's build a smoke scene from the shelf. So create a torus and choose wispy smoke. And let's add the turbulence and also make the padding a little bit bigger for the positive Y. So, and let's take a look at the scene. It's this one. Okay, let's just add a volume visualization to make the smoke bigger. So, and I have camera and light for that. So we can get the information of the smoke by a vex function called volume sample or volume sample v. For example, I want to know the velocity value of the smoke at this position. Then I can write volume sample v because the velocity is a vector. So the first input and the name of the volume is called val and the position of this point. Then this function would return the velocity value of the smoke at that position. Let me use a point to show the process. So let's create a point. I have a good value for that. And let's make it red so it's easier to see. And tablet the smoke like so. Then create a wrangle and plug the volume into the second input. Let's declare a vector variable called volume underscore velocity and use volume sample v for vector field. Second input, the name is val and the position is at p. And I want to move my point by negative volume velocity multiplied by 0.05 unit. So you'll find that the point is moving. So let me copy the wrangle first a couple of times and rewire it. And let's see the progress. So the position of the point is here, and then each time it moves along the negative velocity of the volume. So finally we can sample the density value of this position, also by a wrangle, and connect volume into the second input as well. So again, okay, first let me create an attribute called den, stands for density first, and then still use volume sample without v because density is a scalar volume. So second input, the name is density and position is at p. So let's take a look at the spreadsheet. So you can find here the density of this position is 0.144973. So let's apply the code onto our volume. This time, create a volume wrangle. Let's template. Okay. I need two variables for now. So vector sample underscore p and again val. So the sample p is for accumulating the change of the position. The other one is the same, volume val, to store the result of the velocity of the volume. So the initial value for sample p is current position. Now let's push our position, sample position around, just like we did for a point. First, let's update the velocity of the volume. Again, use a volume sample v, and this time is the first input, the name val, and the sample position, and then change the position again, the sample position p by the negative volume velocity multiplied by 0.05. Okay, so this part is the same as before, so let's do this a couple of times. Let me press Alt E to make it bigger. say we are happy at the position of the sample P. So let's replace our density with a new value sampled from this new position. So the density of this voxel is density equals, again, column sample. The first input this time is density, and the position is the final position, sample underscore P. So let's see the result. As you can see, it changes. So it worked, but now the code looks very repetitive, ugly. So let's make it more concise and clean. So let's replace this part with the for loop. And let's do it 6 times. And indent this part. And we can delete all these lines altogether. And let's apply it. So you can see they didn't change. So this code is valid. And then let's promote some variables to the parameter panel. For this one, we can call it just times, how many times we want to push the sample position around. And I need another variable called, let's make it a float and call it time inc. Stands for time increment. So let's also promote this one and name it time inc as well. And copy it, replace it here. So we know that the distance is decided by the velocity and time. So a good value for time inc is 1 over FPS. But it also depends on the look you want and also how fast the smoke is going. Okay, so let's do this first. There's no error, and click the promotion button and set the time inc as we just mentioned, 1 over FPS, and the default times we use maybe 8. And let's save this as a preset so it will be easier to use later. We call it GA and save it. So it's here. So let's delete it and create a bottom angle again. And try the preset. It worked again. Now we have the tool. Let me show my way of using it. In order to get more data to work with, usually I use the volume resample to increase the data. So let's change the resolution scale to 3. This is for 1 dimension. So I get more data to work with. As you can see here, originally it's like 30 something, and now it becomes like 100. And in this case, I just need to upgrade density and velocity, like so. And then you can see we have already increased some details, and it looks sharper. And let me adjust the parameters a little bit. For example, let's decrease this by maybe 6 something, 0.65, and maybe just do it for 6 times. Let's compare it. Yeah. And we can again use a pattern resample to upraise it. This time just twice in one dimension. And then we can change the filter to sync. You can try different filters. Some is blur, some is for sharpen, and you can compare the result. And then similarly, we just add another wrangle and use our GA preset and take a look. I think it's too much. Okay. So let's make it this one smaller, like 4, and push it for maybe just also 6 times. Okay, so let's compare this one with the original one. As you can see here, the difference is quite obvious. And you might wonder that why the bottom part looks weird. This is because if we take a look at the original smoke, there's no density below this torus. So when we sample it at the new position, in this case, there won't be any density in this area. So that's why it looks weird, because some part will be empty, especially around the edge of the torus. But for the other part, the shape is quite similar. So that's it for today, and thank you for watching. Bye.